In this video, we will do some more examples of arithmetic progression. So the first example is find the sum of all natural numbers between 250 and 1000, which are exactly divisible by 3. So the solution of this problem is, so the first thing we have to do is to find the numbers which are exactly divisible by 3 between 250 and 1000. So if you see, 251 is not divisible by 3 and 252 is divisible by 3 because 3 into 84 is 252. So 253 is not divisible by 3. Next is 254 is also not divisible by 3. 255 is divisible by 3. And similarly 258, 261. So here you can see we already find the first term, which is 252. And if you see, our common difference is 3 because a2 minus a1 is 255 minus 252, which is 3. So our first term is 252 and the common difference is 255 minus 252, which is 3. So in order to find the sum of the arithmetic progression, the formula is n by 2 2a plus n minus 1d. So here we already know the first term and the common difference. So but we don't know the number of terms, which is n. So we will write our arithmetic progression. So we will write all the numbers between 250 and 1000, which is exactly divisible by 3. So here we have to find our nth term, which is also known as an, or we can say our last term, which is known as l. So here 1000, and if we decrease one number, it's 999. So you can see 999 is exactly divisible by 3. So our nth term or the last term is 999. Our formula for the nth term is a plus n minus 1 d. We know that the nth term is 999. First term we already find, which is 252 plus n minus 1, and our common difference is 3. So 999 minus 252 is equal to 3 into n minus 1. So 999 minus 252 is equal to 747, which is equal to 3 into n minus 1. N minus 1 is equal to 747 divided by 3. So if you see, it's 3 into 249 is equal to 747. So n is equal to 249 plus 1, which is equal to 250. So we find the number of terms, which is 250. So our n is equal to 250. The first term is equal to 252 The common difference is equal to 3. So in order to find the sum of the arithmetic progression, we have two formulas. One is n by 2, 2a plus n minus 1d. And if we have first term and last term, this formula becomes n by 2a plus l. L is also known as the nth term, which is an. So here we have n, the number of terms. We also have the first term. We also have the last term, which is 999. So we can use this formula instead of this formula because it is easy to calculate. So here Sn is equal to n by 2 a plus l, and we already find is 250 divided by 2. Our first term is equal to 252, and our last term, which is also known as the nth term, is 999. So here 250 divided by 2 is 125, and 252 plus 999 is 1251, and 125 multiply 1251 is equal to 156,375. So sum of this arithmetic progression comes out to be 156,375. The second example is we have to find the sum of the following AP, which is given as a plus b, a minus b, a minus 3b to 22 terms. So which means the n is given as 22. Here our first term is equal to a plus b, and to find the common difference we have to subtract the second term and last term, which is a minus b minus a plus b. So here a minus b minus a minus b, a minus a is 0, minus b is minus 2b. So our common difference is minus 2b. So we have our first term, which is a plus b. The common difference we already calculated, which is minus 2b. The value of n is already given, which is 222. So in order to find the sum of this arithmetic progression, we will use the formula n by 2, 2a plus n minus 1d. So we can't use the other formula, which is n by 2 a plus l, because we don't have the last term, which is also known as the nth term. So here the n is equal to 22. The value of a is a plus b. The value of a n is 22. The value of d is minus 2b. So here 2 into 11 is 22. 2a plus 2b. 22 minus 1 is 11 into minus 2b. Here 2a plus 2b. 11 into minus 2b is minus 22b. So here 11, 2a. 2 minus 22 is equal to minus 20. So 2a minus 20b. So if we take 2 common from this equation, it becomes 11 into 2, a minus 10b. The final answer is 22 into a minus 10b, which is the sum of this arithmetic progression. Let's do one more example, which is, so we have to find the sum of all natural numbers which are divisible by 5 but less than 100. Solution is, so between all the numbers starting from 1 up to 100, we have to find the numbers which are exactly divisible by 5. So here, if we start from 1, 2, 2 is not divisible by 5, 3, 4, so 5 is divisible by 5. So the first term is 5. So the next term is 6, 7, 8, 9 is also not divisible by 5. Next term is 10, which is divisible by 5. So next will be 15, because 5 into 3 is 15, 5 into 4 is 20. So we also have to find the last term, which is also known as the nth term. So if we see 100, 99 is not divisible by 5, 98 is also not divisible by 5, 97 is also not divisible by 5, 96 is also not divisible by 5, 95, yeah, 95 is divisible by 5 because 5 into 19 is 95. So we find our last term, which is 95. So here our first term is equal to 5. Common difference is 10 minus 5, which is also 5. So our last term or the nth term is equal to 95. So with the help of the nth term, we will find our number of terms, which is n. So the formula for the nth term is equal to a plus n minus 1d. So nth term is equal to 95. So our first term is equal to 5. Number of terms we have to find, and the common difference is also equal to 5. So here 95 minus 5 equal to 5 into n minus 1. 95 minus 5 is equal to 90, which is equal to 5 into n minus 1. So the n minus 1 is equal to 90 upon 5. So here n minus 1 is, as 5 into 18 is 90. So n minus 1 is equal to 18. So n is equal to 19. So our first term is equal to 5. The common difference is also equal to 5. N is 19. The last term was equal to 95. So we can use a second formula, which is n by 2 a plus l. So here n is equal to 19. First term is equal to 5. The last term is equal to 95. 19 over 2 into 95 plus 5 is 100. 2 into 50 is 100. 19 into 50 is equal to 950. The final answer is 950. Let's do the next example, which is we have to find the sum of all natural numbers between 1 and 201 which are divisible by 5. So solution is, so firstly we have to write the numbers between 1 and 201 which are divisible by 5. So the first number will be 5, second number will be 10, third will be 15, similarly fourth will be 20. And in order to find the last term, if you see 201, 200, yeah, 200 is exactly divisible by 3 because 5 into 40 is 200. So here our first term is equal to 5. The common difference is 10 minus 5, which is 5. The last term, which is L, or we can also write as AN, is equal to 200. So in order to find the sum of this arithmetic progression, we have to find the number of terms, which is n, and we can find the value of n with the help of the nth term. The nth term is written as a plus n minus 1d. So an is equal to 200. First term is equal to 5, n we have to find, and the common difference we already calculated is 5. So here 200 minus 5 is equal to 5 into n minus 1. 200 minus 5 is equal to 195, equal to 5 into n minus 1. N minus 1 is equal to 195 divided by 5. So here n minus 1 is equal to 5 into 39 is 195. So the value of n is 39 plus 1, which is 40. So we have our first term, which is equal to 5. Common difference is 5. The value of n, which we already calculated, is 40. And our last term, or the nth term, is equal to 200. So we can easily find the sum of this arithmetic progression by using the formula n by 2 a plus last term or the nth term. So here the value of n is 40. First term is 5. The last term is 200. 2 into 20 is 40. 20. 200 plus 5 is 205. And 20 into 205 is 4100. This is our final answer. Let's do one more example, which is we have to find the sum of integers between 100 and 500 that are divisible by 9. So the solution is, we have to first find the numbers between 100 and 500 which are divisible by 5. So if you see, 101, 102 is not divisible by 9, 103 is also not divisible by 9, 104 is also not divisible by 9, 105 is also not divisible by 9, 106, 107. If you see 108, 12 into 9 is 108, so 108 is divisible by 9. So next we can write is 117, because 13 into 9 is 117. So next one we can write is 126, because 14 into 9 is 126. So we have to find our last term also, which is also known as the nth term. So you can see is 500. So 499 is not divisible by 9, 498 is also not divisible by 9, 497 is also not divisible by 9, 496 is also not divisible by 9. So if you see 495, so if you calculate 9 fives are 45. Yeah, 495 is divisible by 9, because 9 into 55 is 495. So here our first term is equal to 108. Common difference is 117 minus 108, which is equal to 9. Our last term or the nth term is equal to 495. So with the help of the last term, we will calculate the number of terms, which is n. So here an is equal to a plus n minus 1d. Our an is equal to 495. The first term is equal to 108. Common difference is equal to 9. 495 minus 108 is equal to 9 into n minus 1. So here 495 minus 108 is equal to 387. Is equal to 9 into n minus 1. So n minus 1 is equal to 387 divided by 9. So 9 into 43 is 387. So the value of n is 43 plus 1, which is 44. So the value of first term is equal to 108. The value of common difference is equal to 9. The value of n we already calculated is 44. The value of an or the last term is equal to 495. So we can use a formula n by 2 a plus l. The value of n is 44. The value of the first term is 108. The value of the last term or the nth term is equal to 495. 2 into 22 is 44, so 22. 495 plus 108 is equal to 603. 603 multiplied 22 is equal to 13266, which are our final answer. So the sum of this arithmetic progression is 13,266.